Have you ever picked up a Lego model, maybe a spaceship, a tower, a Technic vehicle, or a camera, and wondered how it stays together so well? These models are built from tiny plastic bricks, yet somehow they are strong, balanced, and even functional. Today, I want to teach you how that works. I've been building Lego for years, and one thing that always fascinates me is the engineering behind the creativity. A lot of people enjoy Lego building, but they do not realize how much design work goes into every set. Behind the scenes, Lego designers use real engineering concepts like structural support, symmetry, and load distribution to make models stable and impressive. So today, I'm going to walk you through how Lego engineering works, not to persuade you to like Lego, but simply to explain the process behind the builds. Let's start with the foundation of Lego engineering, structural support. Lego designers use overlapping brick patterns, often called brick bonding, to make builds stronger. Instead of stacking bricks directly on top of each other, they stagger them. According to the Lego group, this spreads pressure across multiple connection points and prevents weak spots. It's a simple technique, but it's one of the main reasons Lego models do not fall apart when you pick them up. Designers also use internal support structures. The Lego Engineering Design Principles Guide explains that many large models include hidden skeletons made from Technic beams or reinforced bricks. These internal frames act just like steel beams inside real buildings. They carry weight, they maintain shape, and they keep the model from bending or collapsing. You might not see these supports from the outside, but they are doing a lot of work behind the scenes. Now that we understand how Lego models stay strong, let's look at how they stay balanced. Symmetry is essential in Lego engineering because it keeps the models visually and structurally even. The Lego Group's Designing for Balance article explains that symmetrical builds reduce tipping and leaning, especially in tall or wide models. If one side is heavier than the other, the whole structure becomes unstable. Symmetry also makes models look better. When designers mirror shapes and patterns, the model looks cleaner and more polished. Even simple builds look more professional when both sides match. And once a model is strong and balanced, designers still have to make sure it can support its own weight, especially if it moves. Load distribution ensures that Lego models do not collapse under their own weight. Designers use Technic elements, beams, pins, axles, to spread weight across multiple points. The 2024 LEGO Technic Structural Survey explains that these pieces transfer weight away from fragile areas. Instead of letting one brick carry all of the pressure, Technic parts spread the force across the entire structure. Load distribution is especially important in moving builds. Hinges, gears, and rotating joints all create pressure when they move. Lego engineers design these parts to spread force evenly so that the model can function smoothly without damaging the structure. If you have ever built a Lego crane, car, or robot, you have seen how these moving parts rely on careful engineering. So let's bring everything together. Today we looked at how Lego engineering works by focusing on structural support, symmetry, and load distribution. These concepts help Lego designers create models that are strong, balanced, and functional, all while staying creative and fun to build. Understanding these ideas help us appreciate the engineering skill behind every Lego set and shows how even simple bricks can become complex, stable, and impressive structures. Lego building may look like play, but behind every model is a world of engineering that makes it all possible.